Hello everyone, this is James Shore with another test-driven development video. It is still January 30th, 2012. In my last video I said that I was going to pause and upload the videos and get comments. But as I was editing them together, I was inspired to keep working on the user enter dollars problem. Because it's actually turned into this really interesting problem where we have a combinatorial problem where we want to use multiple dispatch. We want, every type of dollars needs to know about every other type. So if you're just tuning in, what we're doing is in the process of trying to get persistence working, that is file saving working, we discovered that figuring out what to store was a problem because right now this type of information, an invalid value or value with cents on it, with pennies on it, we didn't keep that information. We didn't have access to it to save it. All we had was what was invalid dollars. So to resolve that issue, I decided to, I was inspired by a commenter on my blog, Quamrana, who suggested that we just save the original text, which, was like a light bulb going off. And the way I decided to approach this was to create a new class, a subclass of dollars called user entered dollars, which would keep the original string that the user typed in and would also do the parsing, so it's actually cleaning things up nicely. So it's going to keep the original string and then use the other dollars to actually do the calculations and so forth. It's a neat idea, I like it, but what we're finding is that for methods like plus, for example, we have to know if it's an invalid dollars, we have to know if it's a user entered dollars, we have to know the types of the data, and that's not good. That's a really clear design smell. Now in the last couple of episodes I was just sort of hacking away at this problem, but I had a chance to pause over the last couple of hours as I was editing the videos and taking care of some other business, and that gave me a chance to think of a new approach. What if when you have a multiple dispatch problem like this, what you want to do is introduce some sort of intermediate form. And I think in this case, the intermediate form, since we're talking about calculations, I think the intermediate form is the amount. So what I'm thinking is that we want a protected method, not a public method, just a protected method that any class can use to provide the core data type, which in this case is the double. And then once we have that, then this method goes away, this amount method goes away. And the question of how do we figure out what we've got goes away. Now we just look at whether or not it's valid. If it is valid, we get the amount. If it's not valid, we do something else. So yeah, that's what I'm thinking. Let's give it a try and see how it works out. I think I'll start out by saying in user entered dollars, rather than adding this as an abstract method to dollars, which it will have to be eventually, and then having to implement it all of a sudden, everything, I think what I'm going to do is I'm going to add it as I'm going to add it to each of these, the concrete classes for dollars, and then come back to valid dollars. So let's start out with invalid dollars test. No, let's do valid dollars test first. I think that'd be the easiest. So we've got is invalid, and then another thing, which is like is invalid, to provide some information about these subclasses. This will be a double, not public, it will be protected, and it will be the to core data type. I'm going to put a comment here to resist the temptation to make this public. That's a design smell. Because once I introduce this method, it's going to be very tempting to make it public. And I wish that Java had a modifier, security modifier, that was just the classes in the class hierarchy. I believe that, I don't remember all the details of Java, but I'm pretty sure that protected means that any class in the package can access it as well as subclasses. It's not quite what I want, but it'll have to do. So what we want to do is we want to assert equals. We want to say that $20 dot toCore data type equals 20. And of course that doesn't exist. No, we don't want to do that. $20 is $1. Okay, so I think for now, I want to show that I'm getting all of the data out. So let's do it this way. And this is a test, so we're not returning the double. That will come later. And then toCore data type. Okay, that doesn't exist. In fact, oh, there's not a way for me to, boy, this is making my life difficult. This should probably, well, I can't return a valid dollars. This method here has caused me more grief. Well, there. Now it's going to put it in the right spot. Thank you. Turn 0 to start with, and let's put this up here. And we want this to be protected. Unlike this, I got confused. There. Well, I think the delta is 0. Yeah, expected that, but was that. That's good. Now we'll return the amount. Yeah, there we go. Now, now this looks promising. So in invalid dollars, I just want core data type I want that to fail. See if I can remember how this works. Let's just have it fail fast, so we'll call it an assertion. That would be a unreachable code exception. I do this so rarely, I don't remember how it works. Oh, it's probably just not happy about me not being done. There we go. There. Now, the reason I'm specifying that two-core data type should throw an exception in this case is because it doesn't make sense. There is no core data type for an invalid dollars. So rather than somehow work around that issue, I just wanted to throw an exception. This method should never be called. That would signal some sort of programming error. Yeah, that will come later. So let me make a note. Need and in fact we need that here as well. Okay, so now that that exists, this test should fail. It should expect that exception and not get it. Yep. And now we'll just so that test should now pass. Good. Now we're getting somewhere. And here in user enter dollars, we'll just expect this to use whatever's underneath. I'm not going to test all the cases because it's just going to be really simple, I think. So we'll test that, and we'll test and the important thing here is the core data type is the core data type of dollars, not the subclass. So the core data type of user enter dollars is actually the string, but the whole package of classes, dollars, valid dollars, invalid dollars, and user enter dollars, its core data type is the double. And that's what I mean by two-core data type. And I'm not calling it two double because I want to emphasize that this is the core encapsulated data type of the class. That's why it's supposed to. That's why it can't stay public or can't be public, because that would violate encapsulation. So we'll make that. And in fact, I think I'll rename this to be two encapsulated data type. Let's see, and this is going to return 0 to start with. That will fail. Oh, I always forget about that. It should be exact, because we're not doing any math on it. Yep. There. That's not going to work. And this is where we finally get that override in. There we go. Now what's it complaining about? A little bit of housekeeping. And hopefully that will pass. It does. Awesome. And that is all the time we have for this episode. So thanks very much for watching, and I will catch you next time.